Hello everyone, today we are taking up the topic of squeeze theorem or the sandwich theorem. We know for numbers that if we have an inequality which says that A is less than or equal to B less than or equal to C, and if A is equal to C, then obviously B will also be equal to A and C. The same result can be extended to limits, that is, if we have a function say gx which is sandwiched or squeezed in between two functions fx and hx, that is why the name sandwich theorem or squeeze theorem. So, if g is a function whose least value is fx and maximum value is hx, and if we find the limit of f of x, find the limit of h of x, and we get that both their limits are equal, that is limit of fx is equal to limit of hx, say L, then g will also have the same limit because both these values are L, so g will also have the same limit L. Now, let us understand this with an example. Suppose the function f of x is x plus 1 and h of x is x square plus 1, and we are given that g is sandwiched in between or squeezed in between f and h. Now, the question is to find the limit of g of x when x tends to 1, that is, we are taking values in the neighborhood of 1. Okay. So, this is what we have to find. So, instead of finding g, which we do not know, we will find limit of fx when x tends to 1, and the denominator being 1, we can directly put the limit value is 1 plus 1 2. Same way, let us find the limit of h of x. This is also 2. Since both the limits are 2, we have that limit of gx when x tends to 1 is 2, because both of these limits being 2. This is an important result which is used to derive the value for sin x upon x. Now, in fact, we have an inequality which says that x cos x is less than or equal to sin x less than or equal to x. So, from here on dividing each of this function by x, we have cos x is less than or equal to sin x upon x. So, we need to find the limit of sin x upon x when x tends to 0. In order to find this, let us find the limit of cos x when x tends to 0, which is 1, and limit of the rightmost function, the constant function, which is also 1. And since sin x upon x is a function squeezed in between, the limit of this will also turn out to be 1, because this is 1 and this one also has a same limit. So, this is one approach of finding the limit of sin x upon x when x tends to 0. Another one I have taken up in a previous video, you will find the link in the description below. Hope that will make you understand the topic better. So, this is about the squeeze theorem, wherein you can find the limit of a function which is squeezed in between, even if you do not know the function, and at times when it is difficult to find the limit using that function itself. So, that is all for this video. Thank you. See you in the next one.